To me, it just sounds like you're saying you can always go, but it doesn't sound like you're getting paid for it. The way he's read.
Yeah,
It doesn't let me on still.
What do you think?
Okay.
We'll start refining it.
Right.
That's exactly what I want.
Hey, am I going to agree?
Okay, well, let's talk about this problem that I have written up on the board, okay? And this is pretty much in your first section that you'll be looking at. Let's talk about this because it's a pretty important thing to talk about. I mean, all they're asking you to do with this thing is simplify it as much as possible, okay? And there's not too much you can do with this unless you can do what? You can factor something out. Now, the top, you cannot factor the top. Why not?
Because of the difference of two squares?
It's the sum of two squares, and it's not factorable. So there's nothing at all you can do with the top. So this just stays like this. Okay? How about the bottom?
Yeah.
You can factor that out.
You can
Take out the y.
You can take out the y, right?
Yeah, that makes sense.
Is that all you can do with that?
Yes. No.
Next to y without the top and bottom.
I told you that.
Yeah, that's all you can do.
Yeah, that's as far as you can go with it. If you can't do anything else. How about if you have a situation like this? What do you do in a situation like this?
Back to the bottom and the x minus 3, x plus 3.
The only thing you can do is you can do this. You can say, okay, x squared, and then this becomes x minus 3, x plus 3. Now, that's pretty critical. That's pretty critical. And what's critical about this particular problem? There's something critical about this problem, right? What is it? It's called the domain. Do you remember when we talked about in Math 11:11 about the domain and how important the domain was? What do we mean when we say domain?
What the bottom cannot be. What the bottom cannot equal. Maybe.
Yeah, well, when we say the domain, and the thing about it is you're supposed to be deciding on what numbers that you're allowed to use in the problem. It is probably a lot easier sometimes to try to determine what numbers not to use versus the numbers that you can use. Okay? So keep that in mind. It won't always be the fact. But in this case, especially this case, you could look all your life and say, well, gee, man, there's all kind of numbers you can use. So why don't you look for the numbers that you're not allowed to use? What numbers are you not allowed to use in this problem?
3 and negative 3.
3 and negative 3. And the reason why is because that would put a 0 in your denominator. Now here's the neat part about this, you all. The times that you must be concerned about a domain. There's only a couple of times in this course. Now there's in other courses, higher level courses, you may be concerned more about a domain than you are in the Math 11:11 or the Math 11:13. But let's stop for a second and say, look, try to make this as easy as possible. Only 2 times that you're going to be concerned about the domain. And that is when you have been given a rational function. Okay? What is a rational function? It is a function that is in fractional form. That is certainly in fractional form, right? That's when you must be concerned about it. It is when it is in rational form, okay? Or the other time is when you are dealing with a square root or an even root problem. Most in this case what? A square root. What about the square root? What about the square root? What about when you have a square root? What would be the domain in that problem?
I'll remember, just kidding. I ain't gonna say.
Do you have to be concerned about it when it's a square root? Yes.
It can't
Why?
be negative.
Because, listen to me, the discriminant has to be a positive number. The discriminant has to be greater than or equal to 0. You know what the discriminant is?
Number inside of the root thingy.
That's the discriminant. So it's x minus 3 has got to be greater or equal to 0. That says that x has got to be greater or equal to what? 3. That's the domain in this problem. X has to be greater than or equal to 3. Do you see that and do you understand that? Simply because what happens if you put a 1 in there for x? 1 is certainly not greater than 3. So try to put a 1 in there, you get a what?
A negative number.
You get an imaginary number. You get, what is the square root of negative 2? So you have to be concerned about it when it's the square root. Or if it's an even root. Odd root, no problem. Because look at this. What is this? Do you have an answer to this?
No, because it's negative. No, because it's negative.
Yeah, it's odd. Because it's what? It's an odd. Can you have the cube root of minus 8? Yes. It's what? Minus 2 times minus 2 times minus 2 is what?
Minus 8.
Right?
Yeah.
Everybody see that? So, okay. 2 times, you have to be concerned about the domain. That is when it's in a square root form, or whether it's in what? A rational form like this. A rational problem, which means it has to be what? Like a fractional form. You cannot have a 0 in the denominator. So, let's stop a second and take a look at this problem here. So, what does it mean when you have a problem like this? Graphically, it means you know what those are called? Those are called brick walls. Those lines are brick walls. They're called vertical asymptote lines. A vertical asymptote. That means that if I'm not allowed to put in a 3 or a minus 3, then what happens when you get very, very close to the 3, you do not ever cross this line. It probably does something like this. And then according to what happens in here, you will have to do what? You'll have to pick some numbers and pick and choose some numbers in here that either make this thing do this number, it could do this number like this, or it could do this or this. It's not going to cross these lines. Are we okay so far about the graphing of the thing and also the vertical asymptote lines? Everybody okay with that? Pretty much so.
Can you spell asymptote for me?
Asymptote?
Yeah.
I don't know.
Yeah.
A-S-Y-P-O-N-T-O-P-E or something? Asymptote?
Asymptote. Okay. Thank you.
Vertical asymptote lines. Now, let's back up a second and say, let's suppose that the problem looked a lot like this. What if the problem looked like that? So this would become what? Right? Does everybody recognize what you can do?
Yes.
What can you now do?
+3.
Could I cancel this and this?
Yes.
Yes. So, since I have someone in the numerator that lent me a helping hand, which I did, certainly that has to make a difference in my problem. And it does. But it doesn't make a tremendous amount of difference about the domain, because you are still not allowed to use a +3 or a -3. You are still not allowed, even though you've got to cancel out the bottom. Does everybody see that? Now, they say, okay, it didn't matter about the plus or -3, it had to make a difference in some way, shape, or form. Well, this is what happens. Instead of, because someone lent you a hand, a helping hand from the numerator, that lent you a helping hand to help you out in the denominator, that allowed you to cancel away, you can now do this with this vertical asymptote line at the -3, okay? There's the -3, still there, okay? The -3 is still there. So, you say, okay, now, what happens with that? This is what happens, everybody. You'll have something that looks like this. It'll still come around like this, but as you get to this point right here, guess what happens? You have a hole in the graph at -3. That's why you still cannot step on -3. You cannot step on -3 because why? It's undefined at that point because that's a hole in the graph. That is the difference. Instead of having a what? A vertical asymptote line, it changes it to an undefined spot. In other words, you cannot travel or traverse along here with your pencil continuously along here to here, because once you reach this point, you're a goner. You're gone. You've gone into some other dimension or whatever. Nobody knows really what happens. They just know you just don't tread on what? The -3. You just don't tread on the -3. Is that fair enough? Does that sort of answer your questions about this? What is your domain in that problem? What is your domain in that problem that I have on the board?
X is not equal to ±4.
No.
What is the domain of the problem that I have written on the board?
All real numbers.
All real numbers except 4.
Yeah, except ±4.
No, because
Say it
it's
louder.
not.
Say it louder.
All
Say
real
it,
numbers.
say it louder what you
All real
said.
numbers,
All real numbers.
because it's not
Now,
numbers.
you cannot make that denominator 0. Be my guest. Try to make the denominator 0. Why is it not 0 ever?
You can't.
It's the sum of two squares. You cannot make the denominator 0.
Oh, yeah. Sorry.
Do I now? Somebody had a question? So, you have to be careful about this, because this is the sum of two squares. You cannot make it equal to 0. We saw this the other day, right? Because why? What does the graph of this look like? Y is equal to x squared plus 16. It looks like this, right? Looks like that. How can it possibly be 0 when the line does not even touch the x-axis, much less cross it? You remember our class the other day? What did we talk about? We talked about what? Behavior of the endpoints and stuff like that, right? We know that's an even power, right? It goes up on both sides. If that had been what? X squared minus 16. Then, if this had been this, y is equal to x squared minus 16. This is always factorable because it's the difference between two squares. And you can make it equal to 0 simply because minus 4 plus 4. It does that. There are what? There are two solutions to this problem. Two solutions. And what is the two solutions? X equals what? 4. X equals what? Negative 4. This is a solution set of odd what? Multiplicity. This is a solution set of odd multiplicity. Why? Because how many negative 4s do you see? Just one. How many positive 4s do you see? Just one. And 1 is an odd number. What is an odd number? So if you have something like this, if you had about that would be what? Not this, but everybody see this now? How many solutions are there to this problem?
4.
4. And what are they?
4.
We know negative 4 and what? Plus 4. We know there's 2. What's the other 2?
Zeros.
You have to name both of them. Why do you have to name both of them? Simply because you have to count every single one of them, because it's important to know that the solution set of 0 is on even multiplicity because there's 2 of them. So if you had to graph this problem, like so, the solution set is this, there's this, minus 4, plus 4, there, even power, positive coefficient up on both sides, right? So negative 4 is odd multiplicity, means what? It goes through the x-axis. That's the way it has to be graphed, like that. That's why you have to name every single solution, even though it's the same solution, same number. That making sense, everybody? Making sense? if I can find some that's. Okay, if you, of course, now the problems that I'm putting on the board today are just nothing more than what? They're not algebraic equations in any sense of the word. They are what? They're just algebraic expressions. And they may ask you to do what with this? They may ask you to simplify this, or more than anything else, they'll ask you to do what? Thought I heard it.
Factor.
Wrong.
Solve.
I said solve. That was right.
Do I?
Solve.
No, that's not. It's not an equation.
Oh, my bad.
You can only solve equations. Of course, you can do what?
Simplify.
You take this expression. In this particular case, they can ask you to do what?
Graphic.
Rationalize the denominator. That's what they would say. Why do you want to rationalize the denominator? Because, well, they may not like to have a square root in what? In the denominator. So all it means when it says rationalize the denominator is to clean up the denominator in some way. In doing so, hell, you may mess up the numerator, but that's tough. That's somebody else's problem. But let me remind you of something. Don't you forget this, because it's important to know in this class. And I've heard this so many times that you always have to rationalize the denominator. No, hell, you do not. Because there's going to be some times in this class that I'm going to ask you to rationalize the numerator. And in calculus, in most cases, you're going to be rationalizing the numerator versus rationalizing the denominator. So it all depends. So don't let somebody say to you, you always have to rationalize the denominator. Hell yeah, only if they tell you to. Only if they say, rationalize the denominator, then now you do it. Or, if it's left like this, and there's nothing about the numerator, that you may want to consider doing what? Rationalizing. How do you rationalize this denominator?
Multiply it by 1. Multiply it by the square root of 3 over the square root of 3.
Multiply what? The top and bottom?
Yeah.
By what?
Square root of 3.
Let's make this everybody. Okay? Alright?
Just take the test and just add one in front of it.
Everybody see this?
Yes.
We certainly rationalize the denominator. Now, if you had to read that, that would be 5x onto the square root of 3. Sometimes you say it like that. Sometimes you just say what? 5x squared times the square root of 3. Sometimes you may hear it said 5x squared onto the square root of 3. Fair enough? Sometimes I get this, a lot of darn times. Is that the same thing?
No.
Yes.
I was kidding.
See that? I get that quite often. I didn't get that answer. I didn't get the answer they have in the back of the book because the back of the book says the square root of 2, and I got square root of 2. I got 2 over the square root of 2. It's the same thing. They just rationalize the denominator for me. Fair enough? Have at it. Have at it. Rationalize the denominator. Not with a computer. Right? With a piece of paper and pencil. If you get it, let me know. Got it? Not yet? Out. Out. That hurts. Look at that. Where's yours? Out. Okay. I wish it was red. I could spark it out with red.
I might as well wind it out with the Jeez.
That's usually what most people will do.
Who wants to go to
Look,
Texas?
let me show you how to do this.
You do it.
I just like to talk about it.
Yeah, let's see what you got. Oh, she done marked it out before I got over here. I didn't even get the marker back. Uh-oh, I found the red marker. Y'all out now.
Oh, we coming over here now.
Oh, never mind. No, never mind. Oh, my God.
What you got? Anybody got it? Come here, leave me out. Oh, man.
I ain't got nothing but a problem.
You started so wrong.
That's right?
Okay, everybody look here. Put your pencil down before you hurt somebody. Stab somebody out. Okay, everybody look at this. This is a very simple problem if you just thought about doing something. What's this?
2/3.
Let's rewrite this. Do it. Look, you got to get rid of the cube root.
Oh, yeah.
You agree?
So when dividing, don't ask why, just invert and multiply.
Now it's simple. What must I multiply this by to get myself x to the first power? Hey, hell, 1/3 plus 2/3 is what? 3/3. That's an x on the bottom. The top is what?
2. X to 2.
Go back and write that like you're supposed to. Don't you write that in exponential form, you write it in what? Radical form.
Oh, put the 3 and then the 2.
Write it in radical form.
That's a third.
What?
The cubed root of x squared.
It's what?
The cubed root of x squared.
How many of you knew how to do that? How many of you knew how to write it from exponential form to what? To radical form? You know, who said that, Baka? Who said that? Listen to me. Oh, listen to me. It's too simple. You should never forget this because it's so simple. You know why? Because you only have to memorize one problem. Only one. You memorize this one problem, and all the rest of them follow the same suit. And that is this. And if I write this like this, that's the same thing. This is exponential form. This is called radical form. So if I go from exponential form to radical form, then I make myself a radical sign, right? I put this under the radical, right there. I drag the top number and put it right there. And the bottom goes in the elbow. And of course the square root, there's nothing goes there, and the 1 doesn't go there. So that would mean that what? 8 raised to the 2/3 power is the same thing as what? 8 squared. So what is the cube root of 64? 4. You all got calculators. I did it first. Gee. Too simple, really. Now you know how to write it from what? From exponential form to radical form. Should be just like that. Is that correct? Are we okay with that? You forgot. Not anymore. Never forget again, will you? I mean, really, because it's too simple, right? I mean, all you have to memorize is the 1 over there. Just the 1. And notice how the what? 8 to the 2/3 followed suit, just like the 1 over to the left. So it goes to show here, when you had to do this, rationalize this denominator. Gosh, you got to get rid of what? The cube root. Because what's the cube root? X to the 1/3 power, right? So you say, okay, what do I have to do this? What must I multiply this by? And what must my exponent be to get myself an X on the bottom? Well, a 1/3 and a 2/3 make what? X to the 3/3, which is just 1. So if I multiply the bottom by X to the 2/3, I have to multiply the top by X to the 2/3. Is everybody okay with that? That make sense? I hope so. See, the math 1111 is coming back to get you, right? It's coming back at you pretty quickly. So, here's another one. Oh, this is my red. I got to save that. I got special purposes for that being the red one. Here's one right here. I don't know. This is just, I don't know who made all these up. These just came out of the program or whatever. X plus 15. Now they're asking you to do what? They're asking you to solve it. Why can I solve this one?
Because it's an equation.
Because it's an equation. It makes it equal to something. So therefore you can now do what? You can solve the equation for X. So how do you do this? Where do we even start to solve this problem for X? So, what? I heard it.
Square both sides.
Somebody said it. Who said it?
Square both sides.
I heard him. I just won't try to make you say it louder where everybody else up here can hear it. He said what? He said square both sides. Okay? So if you do that, then what do you get when you square this side?
X squared plus 9.
If you ever do that again, I will take a pair of needle nose pliers and pull your fingernails out. That's sinful what you just did. You just committed a cardinal sin in math.
What did he just say?
Yes, sir. Yes, sir. I squared this side, you get what? You get x squared plus 6x plus 9. You do not square, I mean, gee whiz. Boy, you sat there and let him do it. You sat there and let him do that. You know what he just convinced you of? This is what he just convinced you of, whether you realize this or not. He just convinced you your job is to go to the store, okay? And you're located right here. That it's a hell of a lot shorter for you to go all the way down to the corner and go up to the store than it is to go across there. That's what he just told you. And you know well as I know, that is not the shortest path. Going to the corner and making the turn and going up here. You know better. You see that?
I was trying to.
No, I know what you're hearing. I catch them all the time on that, folks. But please, please, please don't do that. When it says square that binomial, it says to do what? It says square the binomial. It says take the binomial like this, x plus 3 times what? X plus 3. And how do you do that problem?
Factor.
You pull
What?
it.
Factor it.
The hell said, who said foil?
Damn.
Hell, that tin foil or what? The hell is foil? What happens when you get to a 2 by 3? You drag out the saran wrap, right? You use foil on the first one, and hell, you're going to use saran wrap on the one that's a 3 by 3. Or a 2 by 3.
Multiply everything.
Just multiply this joker multiplies both of these. And this one has to multiply both of these. Hell, did I use the foil? I don't know. I don't really care. I don't need mnemonic junk to help me remember how to do what? How to multiply. And making sure that I do every single term. It's too simple. Now you're trying to memorize some mnemonic device to help you remember some mnemonic device to help you remember something that's worthless. But all you got to do is just learn the method of doing it. Just do it. I mean, what the hell is that? Just do it?
That's what me and Aaron do.
Dang, Tori. Fretting them out.
And do it without mnemonic methods. You know, you don't need that, John. I mean, you learn the correct way to do something. All right, what was I doing? But anyway, you see what I'm saying. You all know how to do this. I'm not going to go into
I
that.
honestly could not do it without foil.
Is what now?
I probably couldn't do it if I didn't have foil. The mnemonic.
Well, I'll tell you what you do. You keep on using that tin foil. And you be dragging out the saran wrap, see. So, as soon as you get to those, oh, you didn't do this one yet. Somebody finish this up. Hurry up.
1 and negative 6.
What'd you get?
1 and negative 6.
1 and negative 6.
Yeah.
Does everybody see you got two answers? Because this becomes what? X squared. What?
Plus 6.
Plus 5x, right? And that's what? Minus what?
6.
6 equals 0?
Yes.
Everybody see how I did that? I just moved everybody to the left and combined the like terms.
I don't have a clue how you got 5x.
You subtract.
I don't either.
Oh, you
I just
subtracted.
made it up.
Well, okay, something like that.
I just made it up. I ain't about to tell you that.
I got it now. I'm sorry.
See, I wasn't gonna tell you. That's not my job. You know how you got that 5x. I don't have to tell you that. All right, everybody look up there. You see that? Of course, you got a quadratic, all right?
Right.
But, okay, let me ask you a question.
I know
The first thing, everybody listen to me a second. When you get it to a quadratic, it is over. It is absolutely over. You better be grateful for the quadratics because they're probably the most often used equation ever, okay? Probably one of the most important ones of all. For the simple reason, a couple of ways you look at this thing. The first thing you look at is you say, oh gee, I wonder if I could possibly factor this thing, okay? And how long do you spend trying to factor it? No more than what, 15 seconds. If you can't figure it out how to factor it in 15 or 20 seconds, then you move to something else, okay? What method do you move to when that factoring is not in the works and right obvious to you?
Quadratic.
No.
JKN.
No. You look at completing the square. Now look, it's very simple, very, very simple to know whether or not you should attempt to do the completing the square or not. So let's just suppose that that was not factorable like you got it factored real quickly a minute ago. So that was easy. But what if that was not factorable? And you say, well, do I use the completing the square method? And it's simple. You look at, first of all, is there a 1 in front of the squared term? And the answer is yes. If that's the case, then you look at the second number in front of the x term. If that number is an even number easily divisible by 2, then you do what? I prefer completing the square. Because what the heck do you think the quadratic formula is?
Completing the square.
Nothing more than completing the square. That is all. How do you think they got the quadratic formula?
I think Einstein had something to do with it.
Who remembers how to complete the square? Walk through with it. Go, hurry. Who remembers how to do it?
I know you take half of something and square it.
What now?
B squared.
Oh, yeah, y'all making up junk.
B over 2 squared.
Just what?
B over 2 squared.
No, that's not.
B squared minus 4AC.
That's the quadratic formula, girl.
Damn, y'all quit. Stop. Time out. All right, hold on a second before I go crazy.
We should just do the quadratic formula.
Okay, listen to me.
You gotta get -6 on the right side.
Is what now?
Get -6
I think
on
he's
the right
like,
side.
is the second part.
Okay, right. Okay, let's do this. Better than that, let's do this. Y'all listen to me. Y'all, just try to behave for a minute or two, okay? Look, this is
Simplest form.
that is in fact the general form of a quadratic equation. You all agree?
Yeah.
That is the general form. It's really nice when the A value is a 1. Okay? But in this case, it's not. So they said, okay, let's attempt to complete the square. The very first thing you must do is you must make,
Set it to 0.
you must make, listen to me, you must make the coefficient in the front of the square term a 1. And in order to do that, then everything has to be divided by an A. Of course, this is 0. Stays 0. Everybody still with me? Say yes.
Yes.
All I did was divide every. So this now leaves me what? That. Right? Okay? Now, the second step. You must take the number, and this is just a number, everybody. That's just a number. And you move it to the right-hand side. And when you move it to the right-hand side, please, whatever you do, I want you to leave a spot where it used to be. Leave it open. This is now x squared plus bx over a equals to what? Did you see what I did? I left the spot available where that number used to sit. And I did that specifically for a reason. Okay. Everybody with me? Step 3. We must take half of the coefficient of the x term. Let's take the coefficient of the x term, which is that, and take half of it. Everybody with me? That's half of it. Stop typing, damn it, I'm doing some work up here now. You better stop that. You better be listening. This is important. I'm trying to tell you something. All right, what does it say do? What's the next? What's step 4? You are supposed to square this term. And you put it on both sides of the equation. Everybody still with me? Everybody still with me? Everybody there? There. Can I erase this away?
Yes.
Because all I did, took half the coefficient and squared it. I put that on both sides, so, but what actually did you do to the left-hand side? What did you make this into? I made this, purposely fabricated a perfect square, which is what? That's the left-hand side. Everybody okay? Yeah, look, square this and you'll get this back. Trust me. Square this and you get this back. Everybody okay? There. This is your job next. Your job is to do this. And I'll even help you. I'll set it up for you, okay? Ready? Do that. Hurry. Hurry, hurry, hurry. You all getting close?
Yes.
Are you close?
As close as I'm gonna get.
Folks, you know what this is called? This is called subtracting fractions. Subtract just fractions. I don't know what it is about fractions, but students go Christ land. When I taught calculus, trig, whatever course I've ever taught. When I taught it here at Columbus State, guess what happens when students reach fractions? They crash land. I do not know why. When did you learn to do fractions? When did you learn to do fractions? When did you learn to add them, subtract them, multiply and divide them? You want me to tell you? Never. Never.
Yes, I did.
Most of the time, never. You thought you learned how, right? How many of you got the answer? You got it?
Or they see my piece.
Oh, shh. Don't be giving it away.
Get it, purple shirt. I know you know it.
It's more. I don't want to.
Boom. Get the colors right.
Who's got it? Where you at? Let's see.
I don't have it.
What in the world? Holy oh my gosh.
You got it, Hillary?
No, I don't.
That's all
Can you
you
look at my
know.
paper?
Do you sure? Hey, let me get my red pen.
No, I don't look at my paper. I was just kidding.
I'll look at it now.
I look at it.
Oh, you don't have, you want me to mark her paper?
Yeah.
She wants you to get mine and not hers.
No, go on.
Go on, get
Let me
hers.
see. You better fix that paper. You get it?
Hi.
You get it?
Don't play.
What's that, Eric? You got it?
Y'all look, y'all real honest here, just put your pencil down before you stamp somebody. What do you know about fractions when you're being asked to add them or subtract them? You've got to have a common denominator. Do you have a common denominator now?
No.
No! Hell, y'all as bad as the person that did this, who gave the preemie what? 1/4 plus 1/4 is 1/8.
I'll be honest with you.
Not as bad as what some of you just did as I walked around the room. I told y'all the story what happened, right?
Right.
You must get a common denominator. In this case, what is the common denominator? This will work. So that stays the same. It's so simple. It is so absolutely simple. It's what? This is the common denominator. You know how much and how many times A divides A 4A squared? 4A times. And what's 4A times C? 4AC. And now you can subtract them. And you can now subtract them because they got common denominators. It is now what? B squared minus 4AC all divided by 4A squared. That is the answer. So far we now have what? X plus B over 2A squared equals what? B squared minus 4AC all over 4A squared. Do you not see that? It's simple, you all. How many of you are following what I'm doing? Anybody not following what I'm doing? That's because you're not paying attention. Now, take a look at this, folks. You now have it in the situation where you can solve this problem by square roots. If I square root this side, I must square root this side, right? So, guess what? If I square root this side, I am going to just have this. If I square root this side, I'm going to have what? I'll do them individually. Do you see that?
Yeah.
What is the square root of 4A squared?
2A.
2A. 2A. Do you see why it's plus or minus? Yes, it's because it's plus or minus. You square root this side, you square root this side, it's plus or minus. Now what has to be moved over? That crayon. But guess what? This crayon has the same denominator as that crayon. So now it's x is equal to what? Minus b plus or minus the square root of b squared minus 4ac all over what? I can put the whole thing over 2a simply because both of them have the same denominator. You are through. That is the derivation of what? The quadratic formula. How many of you followed what I just did?
Got
Did you follow pretty easily?
yeah, I had a tutor over here that was out here.
Oh, it's okay. You can't listen to him, though.
No, you're right.
No, he did good. Anybody not follow what I just did? Did anybody not care what I just did? I knew you'd do it. You didn't even have to raise your hand. I could guess that. Okay. But look, you should really be what? You should be thinking about, wow, somebody had to come up with a quadratic formula. That's how they did it.
Somebody's got to do it.
It's completing the square. That's all it is. So that's why you do what? You try to complete the square first, because it's the same thing as what? Quadratic formula. Just sometimes it may be a little bit shorter than putting all those numbers in the quadratic formula. Good enough? What is this? Oh, I can erase this away. What? Everybody looked at it?
Yeah.
But that go right But I'm just telling you, came up with the quadratic formula. How good is that? I mean, you do two things, you do more than two things, right? Well, you can never say. He didn't invent gravity.
Knowing what you learned yesterday about the shape of problems and equations stuff, okay? Knowing what you learned yesterday. That should make the quadratic equation really, really simple. Because you have to think about this. When you are asked to do something like that with a quadratic equation, you know immediately that it's going to do what? Be a smiley face or what? A frowny face. Period. Equations that fit this criteria would be what? Profit functions. You own a business, would you want your profit function to look like this? I don't think so. You certainly don't want to try to minimize your profits, do you? You try to do what? You try to maximize your profits. You certainly try to minimize your losses. So those are both quadratics. Those are both quadratics. Knowing where the vertex is located. If you knew the vertex was there, and it had a positive coefficient, how difficult is that? So what is the vertex called? The what?
The vertex. It's just called the
Point of
The critical point. Critical point. Why the hell do you think it's called a critical point?
It's pretty important.
Because it's critical. It's the most critical point on the whole entire picture. See, look what they do over here. They go buy these $1,000 boards over here. They're not worth a damn. Somebody, I could have bought a lot of beer with that. Gee whiz, yeah. I mean, why do you need this junk? That stuff to me is in the way. Burn it. Just wasting time. They go plot those points, you know. I just grabbed the quadratic for you in what? In seconds. How long should it teach you to teach graphing to people, especially linear equations? If you spend longer than a minute teaching students how to graph linear equations, then you are wasting their time. Trust me, you're wasting their time. How many seconds did it take me to graph that equation?
2. She didn't plot the points.
Yes, I did too.
I mean, you don't have the...
Hell, I did too. That right there is 1, 2, 3, 4, 5, 6.
How am I supposed to
Don't you tell me I didn't graph the points. That's for somebody else to junk over here, to go over here and take up hours of your time. The slope of that line is what?
Negative 3 over 8. Rise over run.
Negative 3/8. You see that line? That has a slope of negative 3/8. You don't believe it? Just ask me.
Oh, I believe it.
But you didn't like.
Better, because that's what it is. I said it was.
You didn't define your units. That's what I was talking about.
Find those units.
No, if you tell me the truth one more time.
Uh-oh, hell, almost, I can't use that when I read it in. Go ahead.
Listen.
30 by 50. 30 by 50 building.
1,500 square feet.
Now you're supposed to build that building, okay? But before you get started, you get a call that says, hey, the builder wants you to double the size of it. Duh! How big you gotta build it now?
3,000 units.
How big?
120 by.
What?
Double it. It's 1,500. That's square.
60,
Oh.
60 by 100.
What?
60 by 100.
I hope you got the keys to the truck, because you better get away before the boss gets out there and strangles you. He told you to build it twice as big, not 4 times as big. You just built it 4 times as big.
3,000.
Square.
It's 1,500. It's 30 by 50.
How are you gonna do it?
You're right.
I'm gonna ask my boss if I question myself. But I think it's 3,000.
And don't any of you say, build it 2 stories. Because they sell pianos out of that store, and you're going to go help them on Saturday, take them up and down the steps. That would fit the criteria to double the size of it. Build it 2 stories. Would be the cheapest way to probably do it,
So 6,000.
with the least amount of material. But they want a 1-story building, they want it to what? 3,000 square feet, not 1,500.
I was right.
So what do you do? How long and how wide do you make it to make it 3,000? Hurry, somebody tell me. You've got
100
workers
by
standing here. You're the
300.
boss. You better tell them where to start and stop and dig and not dig.
100 by 300.
Whoa!
Whoa!
God.
Yes, I
I said 100 by 60, so what
Then
makes
you
it
won't get
60
fired, you'll
100
get
by 300?
probably shot.
I don't know. At least I had the 3,000 part.
45 by 75?
Huh?
No.
Somebody said 30 by 100. Okay, that's 3,000. You know what the hell that is? That's the property line. You done built the building on somebody else's land. That ain't gonna work.
Yeah, really.
How do you do this problem, everybody? You've got to do this. You've got to add, we don't know how much to the length of the building, right? We also have to add so much to the width of the building. And now the building is what? There's the new building. So the area has got to be 3,000, right? And it's length times width, right?
Yes.
So what is the length of my new building?
50 plus X.
It is 50 plus X. What is the width of my new building?
30.
30 plus X.